This is the first lesson in Unit 1617, Properties of Line Segments, and what we're looking at today is we're looking at the length of a line segment. So by the end of this lesson, you want to be able to find the length of a line segment using either a graph or, more importantly, using the length formula that we're going to look at. So before we get started in terms of finding the length, just let's compare lines and line segments. We looked at lines at the very beginning of the course, and a line is infinitely long. Like this is the graph of the line y equals negative 3x plus 4, and I put these arrows on the end because this goes off to infinity, like negative infinity and positive infinity in both directions. So it has infinite length. If, on the other hand, I define a line segment, which starts at a particular point and ends at a particular point, so this is the line segment from 0, 4 to 2, negative 2. That line segment has a defined length. So what we want to be able to do is be able to find the length of a line segment like that one. And as we do this, we're going to think back to what we did at the beginning of the course where we were talking about the slopes of line segments, or the slopes of lines. So I've got a line segment here from negative 3, 4 to 6, 1, and we want to find the slope of the line segment. And in grade 9, you learned how to do this using a graph. The slope was the rise over the run. So you drew a little right angle triangle here between the endpoints. And the rise was the vertical change, or the vertical side of this triangle. So in this case, our rise would be negative 3 because our line is going down from left to right. So our slope will be negative, so our rise has to be negative. And our run was the distance across the bottom of this triangle. So 1, 2, 3, 4, 5, 6, 7, 8. Our run is 9. And we can put those numbers into the formula here, negative 3 over 9, and we get a slope of negative 1/3. But we also learned to do this using a formula. And the formula that you have at the top of your formula sheet is that for slope, it's y2 minus y1, x2 minus x1. Now, how did we use this formula? Well, we took one of our points and we called it point 1, or we labeled the x, x1, and the y, y1. And then our other point, we called it point 2, and we said that this x is going to be x2, and this y is going to be y2. And then we just sub those numbers into the formula that we had. So y2 is 1, so we want 1 minus, let's see, our y1 value is 4, our x2 value is 6, and our x1 value is negative 3, so we want to subtract negative 3. And I'm putting that negative 3 in brackets there to remind myself when I go to do that subtraction, because if I do 1 minus 4, I'm going to get negative 3. But I have to think of this 6 minus negative 3. It's like those two negative signs make a positive. 6 plus 3. So this will be negative 3 over 9, or negative 1 over 3. So however we do the slope, we're going to end up with negative 1/3 for the slope of this line segment. All right, so let's turn our attention now to finding the length of a line segment. So I've got the line segment from 1, 2 to 4, 8, and I want to calculate the length of it. If we're given the graph, we can do something similar to what we did with the slope. We can draw this right angle triangle using that line as our hypotenuse, and we can apply the Pythagorean theorem. We can look at this and say, okay, this vertical side, 1, 2, 3, 4, 5, has a length of 6. This horizontal side has a length of 1, 2, 3. And so our length, using the Pythagorean theorem, is going to be the square root of 3 squared plus 6 squared. And then we just evaluate using order of operations. We do the exponents first. Then we do the addition under the square root to get 45. And then we take the square root to get approximately 6.7. Now, it would be nice to have a formula that we can use that would do the same kind of thing. So we can take what we've done here with the Pythagorean theorem and use that to develop a formula for the length of a line segment. If we look at how we got these lengths of these other two sides, we can relate it to these coordinates that we have at our two endpoints. So again, I'm going to label my one point here x1 and y1, and I'm going to label this one x2 and y2. And I'm going to notice here that this 3 that we have here is just the difference between our x2 value and our x1 value. X2 is 4, x1 is 1, 4 minus 1 gives us the 3. And the same thing is true with this, the height of this vertical side here. It's the difference, the length of that little segment there is the difference between our y2 value and our y1 value. 8 minus 2 gives us that 6. So taking these two expressions here as like the lengths of that vertical and that horizontal side, we can say that the length is going to be the square root of that horizontal side squared, so x2 minus x1 squared, and then plus the length of the vertical side, y2 minus y1 squared. And that's the length formula that appears on your formula sheet. So how do we use this formula? We use it the same way we use the slope formula. We've already labeled our points x2 and y2 and x1 and y1. So let's just sub in the values that we have there. Our x2 value is going to be 4. Our x1 value is 1. Our y2 value is going to be 8. Our y1 value is 2. And then we just do the calculation using order of operations like we've been doing all along. We're going to start inside the brackets and do our subtraction. So 4 minus 1 is 3. So we'll have 3 squared. 8 minus 2 is going to give us 6 squared. And then it's just like the Pythagorean theorem calculation that we did up above. We do our exponents. We do our addition to get square root of 45. And then our answer is going to be approximately 6.7. Okay, so the key for this lesson is you want to be able to use this formula here from the formula sheet to find the length. So let's do an example. Again, use the length formula to find the length of the line segment from -3, -8 to 1, -1, -2. So we could use Pythagorean theorem here because we have the diagram, but let's use our formula. So our formula is square root x2 minus x1 squared plus y2 minus y1 squared, straight from the formula sheet. So let's label a point, x1, y1, and we'll label another point, x2, y2. And let's sub those values of x and y into our equation here. So our x2 value is -1, and then we want to subtract our x1 value of -3. And I'm going to put brackets around the -3 to remind myself that it's a negative. And so I'm going to be subtracting a negative when I do that evaluation. My y2 value is -2, and I'm going to subtract from that my y1, which is -8. Okay, now I want to start doing the simplification. I'm going to do the work in brackets first. So this first bracket, -1 minus -3, that's like -1 plus 3. So that'll be +2. And then my second bracket, I got -1 minus -8. That's like -1 plus 8. So that's going to be 6. So I'll have 6 squared. And then I'm going to do my exponents. It's 4 plus 6 squared is 36. So I'm going to get the square root of 40, or putting this into my calculator, approximately 6.3. So notice, had we done this using the Pythagorean theorem, we would have had a length of 2 down here and a length of 1, 2, 3, 4, 5, 6 for our vertical side, which matches what we had here and here for the length of those two sides. All right, let's take a look at ones where we don't have the diagram. So at this point, we should be pretty comfortable. Just starting up with our formula, x2 minus x1 squared plus y2 minus y1 squared, okay? And again, I'm going to label a point, x1, y1, x2, y2. Let's sub those numbers in. Square root x2 is 5, x1 is negative 2. Now, actually labeling the numbers in the questions with x1 and y1 and x2 and y2 is helpful just to make sure you get the correct numbers in the correct spot. You always want to be doing x2 minus x1 and y2 minus y1. That order in there is important. So my y2 here is 6, my y1 here is 10, so I got to subtract 10, and of course this is going to be squared. Now I'm going to get 7 squared plus 6 minus 4, negative 4 squared. But when I square that negative 4, it's going to become positive because negative 4 times negative 4 is going to be positive 16. So I'll have 49 plus 16, or root 65, which is approximately equal to 8.1. All right, and our last one here, we want to find the length of this line segment from 1, negative 5 to 7, 8. This one you can probably do on your own and just pause the video, set it up, do the calculation, and then check your answer. I'm going to start with my formula. I'm going to label my points, x1, y1, x2, y2. I'm going to sub in those values. 7 minus 1, 8 minus negative 5. And from here, it's just calculations. 6 squared, 7 minus 1 is 6. 8 minus negative 5 is 8 plus 5, so that's going to be 13 squared. 6 squared plus 13, doing that calculation all at once, is 205. So my length is approximately 14.3.